All right, rationalizing technique. So sometimes they're not factorable, but a way to find the limits of some functions is to first rationalize the numerator of the function, which is called the rationalizing technique. Well, rationalizing is not a word we use a whole lot, but we've done it before. Remember before when we couldn't have a radical in the denominator? What did we do? We multiplied by the what? What if though it had like the square root of 3 plus 1? What did we multiply by? We multiply by the conjugate. The only difference on this one is that we're having to rationalize the what? Numerator. So you're going to multiply by the conjugate of the numerator, because that's what's going to be causing us problems. Now, what is that going to do? It's going to put a radical in the denominator. No big deal, okay? Because it's not going to be my final answer. It's just giving me an equation that I can take the limit of that will work. Now, what do I mean by conjugate?
Inverse.
No.
The negative of it.
The opposite sign in the middle, okay? So like my pieces here, this piece, the square root of x, and the 4 stay the same, but we change that sign in the middle. So see, we still have the square root of x, we still have the 4, but this time we have a minus instead of a plus. So remember, a conjugate just keeps the pieces the same, but it changes the sign in the middle.
Wait, so there could be 1 on the bottom?
All right, so let's find the limit of this function. First thing is try your direct substitution. Because like before, sometimes it works, sometimes it doesn't. Now, I don't expect this one to work since we're talking about other methods to do it. But on your assignment, I may not say, hey, use rationalizing the numerator to solve this problem. It's going to say, find the limit, okay? And you've got to decide, is direct substitution the method we need to use or not?
But you can find that out by it equaling.
So let's just, well, we can find out by just plugging in what x is approaching to see if it works. So when I do that, I get what? 0 plus 1 minus 1 over 0. We already know we're in trouble there, but I'm going to go ahead and work it out to see if I get that 0 over 0. So I get 1 minus 1 over 0. So we do get 0 over 0, right? So, but can I factor this one? No, but I notice that I have a radical in the numerator, right? So let's work on rationalizing the numerator.
Thank you.
All right. So to do this, we're going to write down our equation that we have there, or the fraction. So the square root of x plus 1 minus 1 over x. And we're going to multiply it by the conjugate of the numerator, which is what?
X minus 1.
The square root of x plus 1
Wait,
plus 1. Remember, the pieces will stay the same, so that radical is going to stay exactly the same. The 1 is going to be the same. The sign in between them needs to change. And what we do to the top, we have to do to the bottom. So we're going to do FOIL on top. So you get the square root of x plus 1 times itself. So I'm just going to write that as the square root of x plus 1 squared. Outside, so I got the square root times positive 1. So it's plus square root of x plus 1. Then I have negative 1 times that square root. So minus the square root of x plus 1. And then negative 1 times positive 1, which is good. And I'm going to put that all over. Now, I'm not actually going to multiply those two. I'm just going to write them out. So it's x times the square root of x plus 1 plus 1. Now, if I need to distribute that out later, I can. Or when I go to plug in a number later, I can plug it in as it is if I want to.
So, I'm confused on why it doesn't work whenever it's the simplest word, where we have to expand it and then cancel things out for it to work.
Because the canceling makes some things that would give us a 0 go away.
So what we can cancel the
All right. Yes. First, though, I'm going to look the square root squared. The square and the square root cancel, right? So bring out your x plus 1. The square root of x plus 1 minus the square root of x plus 1 cancels. And so we got minus 1 over, and I can't do anything in the denominator, so I'm just going to leave it. Now, in the numerator here, my 1's will cancel, right? So I get x over the denominator.
Do we have to distribute that x? So the x's cancel?
Now, I don't want to distribute the x because now these x's will cancel.
Okay.
So what's going to be on top? 1 good over that square root of x plus 1
Oh, you can't have square roots on bottom.
plus 1. It's okay. This isn't a final answer, is it?
Oh.
Yeah, I can have a square root here. It's okay to have it in the denominator because this is not my final answer. You're right. Typically we don't, but this is not a final answer. It's part of my work. It's okay. All right, so can I simplify any more?
Do the ones cancel?
Do the ones cancel?
No.
No, why not?
It's not a negative. Attach it.
The one on bottom is super glued with the plus sign, right?
Why'd you ask if you...
Because... All right, so the next thing we're going to do is we're going to use direct substitution again. But this time we're going to use our simplified form. All right, so remember I want to see it rewritten. The limit as x approaches 0 of your simplified form. So 1 over square root of x plus 1 plus 1. And then actually do your direct substitution. And then just work it out.